Consider triangle ABC. Extend the side BC to the point D. An angle is formed outside the triangle, angle ACD. Such angles are called outer angles or exterior angles of a triangle. At the vertex C, you have an angle inside the triangle, and such angles are called inner angles or interior angles. Here, the outer angle and the inner angle at a vertex form a linear pair. You know that in a linear pair, the sum of the angles is 180. Therefore, here angle ACD plus angle ACB is equal to 180 degrees. Now, extend the side AC to the point E to form another outer angle. Angle BCE is the outer angle formed here. And you have two outer angles at the vertex C, angle ACD and angle BCE. They are opposite angles and therefore they are equal. At a vertex of a triangle, you can make two outer angles and those two outer angles are equal. Now consider a triangle. Make one outer angle at each vertex. Here you have three outer angles, and in a triangle you have three inner angles. At each vertex of the triangle you have a linear pair. The sum of all inner and outer angles will be the sum of the angles in three linear pairs. Therefore, the sum of all angles is 3 times 180. Now you know that in a triangle, the sum of inner angles is 180, that you can write as 1 into 180. So sum of all inner and outer angles is 3 into 180. Sum of inner angles is 1 into 180. Sum of all outer angles is equal to 3 times 180 minus 180. That is equal to 2 times 180. That is 360 degrees. Consider a quadrilateral. By extending the sides, you can make outer angles at each vertex. You have 4 outer angles here and also 4 inner angles. That means you have 4 linear pairs. The sum of all inner and outer angles will be 4 times 180. Sum of inner angles in a quadrilateral is 4 minus 2 times 180, that is 2 180. Now the sum of all outer angles will be 4 into 180 minus 2 into 180, that is equal to 2 into 180, that is 360. Consider a pentagon. By extending the sides, you can make outer angles at each vertex. You have 5 outer angles here, and in a pentagon you have 5 inner angles. You have 5 linear pairs here. Therefore, sum of all inner and outer angles will be the sum of the angles in 5 linear pairs. That means 5 times 180. In a pentagon, sum of inner angles is 5 minus 2 times 180, that is 3 180s. Now, sum of all outer angles will be 5 into 180 minus 3 into 180, that is again 2 into 180, that is 360 degrees. Now consider a hexagon. In a hexagon you have 6 sides. Extending the sides, you can make 6 outer angles. Also you have 6 inner angles. That means 6 linear pairs. Therefore, the sum of all inner and outer angles will be 6 into 180. Sum of inner angles is 4 into 180, and therefore sum of all outer angles will be 6 into 180 minus 4 into 180, that is 2 times 180, 360 degrees. Now consider a polygon with 10 sides. Here, if you make one outer angle at each vertex, you have 10 outer angles and also 10 inner angles. That means you have 10 linear pairs. That is, the sum of all inner and outer angles will be 10 into 180. Sum of inner angles 8 into 180. Therefore, sum of all outer angles 10 into 180 minus 8 into 180, that will be 2 into 180, 360 degrees. Now in general, consider a polygon with n sides. In an n-sided polygon, if you make one outer angle at each vertex, you have n outer angles and also n inner angles, and therefore the number of linear pairs will be n. Therefore, sum of all inner and outer angles is n times 180. Sum of inner angles of a polygon with n sides will be n minus 2 into 180. Therefore, sum of all outer angles is n into 180 minus n minus 2 into 180. That will be 2 times 180, that is equal to 360. Now, in all polygons we have the sum of all outer angles 360 degree. We can write this result as sum of all outer angles in any polygon is 360 degrees.